Hello everyone, welcome to this seminar on what are chips. My name is Sachin Murli Nair and today we'll explore how tiny silicon chips have become the core of our modern technology, powering everything from computers and smartphones to even our cars and TVs. We'll understand how chips are, how they are made, how they are classified, and how they work inside different devices. These tiny components are often overlooked, but they are what makes our devices smart, responsive, and capable of incredible tasks. By the end of the seminar, I hope you will have a clear understanding of the different types of chips, how they function, and why they are so important in the world we live in today. Let's begin. A chip, in simple terms, is a small piece of silicon that contains electronic circuits designed to process information. It's like the brain of any device, telling it what to do. These chips are used everywhere in computers, smartphones, cars, TVs, and even in appliances like washing machines. They are tiny but mighty, making modern life possible. Without these chips, our devices would be lifeless. No apps, no games, no smart features. Every task you perform on your device, whether it's opening a file or making a call, is made possible by these chips working behind the scenes. They truly are the unsung heroes of modern technology. Chips are incredibly important because they power almost everything around us, whether it's a computer running a software, or a phone making a call, or a smart TV streaming your favorite shows on Netflix. It all happens because of chips. They are they also enable advanced features like AI, stunning graphics, and high-speed connectivity. In short, without chips, modern technology wouldn't exist. It's easy to take these tiny pieces of silicon for granted, but they form the foundation of our digital lives. They are what make our devices smart, fast, and capable of doing so much. From communication to entertainment, from automation to innovation, chips are the silent workhorses behind the scenes. Chips come in many types, each designed for specific tasks. For example, CPUs or central processing units are the main chips in computers. SoCs or system on chips are used in smartphones and combine multiple functions into a single chip. GPUs or graphics processing units handle visuals and gaming. There are also ASICs, which are chips made for specific jobs, and FPGAs, which can be reprogrammed for different tasks. We'll explore those in later slides. Each chip plays a unique role in the overall system. Some chips are like all rounders that can handle multiple tasks, while others are specialists optimized for a single purpose. Understanding these different categories helps us appreciate the engineering that goes into modern technology. The Apple M1 chip represents a modern, highly integrated SoC designed specifically for Macs and iPads. It combines the GPU, CPU, neural engine, and other components into a single efficient chip, delivering impressive performance and energy efficiency. This shows how SoCs are shaping the future of personal computing. The AMD Ryzen 9 9900X is a powerful CPU designed mainly for desktops and laptops. It focuses on raw processing power and multitasking capabilities, ideal for gaming content and creation and heavy workloads. This represents the traditional computer chips that prioritize performance over everything. The RTX 4080 Super is an example of a high end GPU designed for advanced graphics processing. It can handle rendering, complex visuals, gaming, and AI computations. showing how specialized chips like GPUs enhance specific tasks beyond general processing. Let's start by understanding CPUs or central processing units. The CPU is often called the brain of a computer. It's responsible for managing tasks and controlling the flow of data. Whether it's opening a file, running a program, or playing a game, the CPU handles it all. CPUs are mainly used in desktops, laptops, and servers. Popular examples include Intel's Core series like the i5 and i7 and AMD's Ryzen processors. CPUs are generally designed to handle a wide range of operations, making them versatile and essential for general purpose computing. They form the backbone of most computing systems, enabling the software to run and the hardware to function smoothly. Next, we have SoCs or system on chips, which are mainly used in smartphones. An SoC is like a all-in-one chip that combines several components: a CPU, a GPU for graphics, a modem for communication, and even AI processing units, all inside one tiny chip. This design makes SoCs compact, energy efficient, and perfect for small devices like smartphones, tablets, and even wearables. Some popular examples are Qualcomm's Snapdragon series and Apple's A series Bionic chips. The beauty of an SoC is that they pack so much functionality into a small space. By combining multiple components into a single chip, SoCs can reduce power consumption, save space, and improve performance. This is why smartphones today are so powerful despite their size. Let's now talk about GPUs or graphics processing units. GPUs are designed to handle graphics related tasks like rendering images, videos, and games. They are also used in AI and machine learning because they can process large amounts of data in parallel. GPUs are found in PCs, laptops, and gaming consoles, and sometimes even in data research centers for AI research. Popular examples include NVIDIA's GeForce series and AMD's Radeon series. GPUs are like a team of workers handling multiple tasks at the same time, making them ideal for complex visual and large scale data processing. They are not just for gaming, they power AI, scientific simulations, and even video editing tools, making them a crucial part of modern computing. ASICs or application specific integrated circuits are chips designed to perform just one specific task. Like CPUs or GPUs that can handle different jobs, an ASIC is custom built for one particular use. For example, Bitcoin mining machines use to ASICs that are optimized to solve blockchain puzzles efficiently. Networking chips in routers are also ASICs. They are very efficient at their job, but you can't repurpose them for any other tasks. ASIC are like precision tools. They do one job and they do it extremely well. They are often found in industries where speed and efficiency matter the most, but their limited flexibility makes them unsuitable for tasks beyond their original purpose. FPGAs or field programmable gate arrays are special types of chips that can be reprogrammed even after they are manufactured. This makes them useful for prototyping, research, and simulations where you need a custom hardware solution. While FPGAs are not as fast as ASICs for specific tasks, their flexibility allows the engineers to experiment and adjust designs without needing a new chip every single time. This adaptability makes FPGAs popular in industries like aerospace, telecommunications, and automotive, where requirements can change frequently. They act as a bridge between hardware and software, giving developers the power to optimize hardware behavior on the fly. Let's compare SoCs and CPUs. A CPU or a central processing unit is designed mainly for general computing tasks like running programs or handling data. On the other hand, an SoC is like a miniaturized system that combines the GPU and the CPU for all sorts of graphics designs, modern communication, etc. AI accelerators are also welded into this chip. This makes SoCs more compact and efficient, especially for smartphones and tablets. While CPUs are powerful and flexible, SoCs offer an all in one solution optimized for smaller devices with limited power and space. This integration helps devices run faster, use less energy, and deliver features like wireless connectivity and advanced graphics seamlessly. SoCs are used mainly in smartphones and tablets, and even in wearable devices where size and power are crucial, also with efficiency. CPUs, on the other hand, are found in desktops, laptops, and servers where performance and flexibility matter more than size. So, while both are processors, their design and use cases are quite different. In essence, CPUs focus on raw performance and multitasking ability, while SoCs integration and energy efficiency. Choosing between them depends on the device's purpose, whether it's a high power computing or a compact battery friendly operation. The future of chips is all about making them smaller and faster, all the while making it more power efficient. We are seeing the rise of AI powered chips, which handle complex tasks like image recognition, natural language processing, etc. SoCs will keep on evolving, integrating even more features into a single chip. We'll also see more specialized chips, like those designed for AI, 6G, and even healthcare applications. Advancements in chip manufacturing, like the nanometer processes and the 3D stacking, will allow chips to pack more transistors in less space. This will lead to devices that are not only more powerful but also consume less energy, enabling longer battery life and even new capabilities in everyday gadgets. Quantum chips are a whole new level of technology. Instead of using binary bits like zeros and ones, they use quantum bits or qubits, which can represent both 0 and 1 at the same time. This allows quantum chips to solve any complex problem much faster than classical chips. While they are still in an experimental phase, quantum chips hold the promise to revolutionize fields like cryptography, AI, and simulations. Quantum computing could transform industries by solving problems that are impossible or would take classical computers millions of years. However, building a stable quantum chip is challenging due to issues like qubit error rates and maintaining quantum coherence. This image shows the Majorana 1 quantum chip, which is a cutting edge example of quantum technology in development. Majorana qubits are special because they are designed to be more stable and less prone to errors than traditional qubits. This stability is crucial for building practical and scalable quantum computers. The Majorana 1 chip represents a promising step towards making reliable quantum computing a reality and potentially revolutionizing fields like cryptography, material sciences, and complex simulations. To sum up, chips are the backbone of modern technology, from CPUs in computers to SoCs in smartphones, and soon to quantum chips. They make everything possible. The future of chips is about becoming smarter, faster, and more integrated. It's a journey that's just beginning, and it's exciting to see where it will take us. As technology advances, chips will continue to shape our lives, powering innovations in communication, medicine, entertainment, and beyond. Understanding these tiny but powerful components helps us appreciate the amazing world of technology we live in. Thank you all for watching this session. I hope you learned something new about the fascinating world of chips. If you have any questions or doubts, please feel free to leave them in the comment section below.